extra feed, supplements, so on. Okay, so this lesson is all about feed digestibility. So digestibility refers to the nutrients that are absorbed by the body. So overall, farmers usually give animals feed, extra feed, supplements, so on. But what is the point if the animal is not actually absorbing and taking in the nutrients that it is eating? So the feed digestibility is all about for the farmer to figure out that whatever he's giving the animal, is the animal actually taking it in, and is it worth his while? Is he losing money, or is it actually money well spent for him to spend extra money on extra feed, supplements, and so on? And is the animal actually getting enough nutrients in? So just at the top there is basically that definition. So digestibility is the portion of feed that have been absorbed physically by the animal's body, specifically for either growth or maintenance. And I just want to mention that there is a difference between growth and maintenance. So growth usually has to do with like your young animals. They're still growing, still building muscle, they're gaining height. Whereas for maintenance, this is it just keeps the animal alive. So usually when a farmer gives feed to an animal for growth purposes, he has to give over and above what the animal actually needs. So he has to give extra that while it's still growing won't necessarily become fat in the animal, but it will actually help it build muscle and grow and become taller. Whereas with maintenance, it's basically just giving enough that the animal needs to stay alive basically from day to day. So these are usually for your adult animals. They're not really growing anymore. You don't want to give them too much, otherwise they become fat. So you just want to give enough to keep them in their current condition and keep them alive. Okay, so then there are a couple of factors that affect your digestibility. The first thing is like your feed composition. So is there fiber in the feed? Is it just plain protein, carbs? What are you giving them? Secondly, which affects how good they absorb the feed, is the preparation of it. Was it just felt you allowed the animal to eat, which has a lot of fiber and cellulose and tough materials, or was it actually prepared by soaking the feed in water, or did you boil it, or did you do something to it? Thirdly, the type of animal. Some animals absorb feed just better than other types of animals. Then also the quantity of the feed. Did you give it enough? Did you give it too little, too much, that type of thing? Then the age of the plant when eaten. So usually your young plants, especially when they're still soft and tender, they digest much, much quicker and easier than your tough, cellulose, thick plants. So it depends on the age of the plant usually. And lastly, for farmers, how can they actually process the food they give the animals to improve the digestibility of the feed? A couple of things. You can grind the feed. Think of corn, usually is ground to make it a little bit more fine. You can boil feed, you can pellet it, so little pellets to make it, especially with chickens, they love picking up the pellets, and then roasting it. Probably usually with roasting, you break open the outside. Let's say it was for seeds or something. Roasting bursts open the outside husk of a seed, and then it's better or easier for the animals to get to the inside, which actually has all the nutrients. And then also crushing feed to make it maybe into a meal format or a flour format. Okay, so from here on, we're doing a lot of equations and mathematical things, so that we have to do a couple of calculations. That's the word I'm looking for. So the first thing is the digestibility coefficient. So this is a mathematical way of figuring out what you have given the animal and whether the feed actually went into the animal, whether the animal absorbed the feed. So the equation here is very important. They do not give the equation in the exam. You have to memorize this out of your head. So the equation here is dry food ingested, whatever the amount of kilograms you gave the animal, but it must be dry, minus the dry feed that was excreted in the manure, also in kilograms. Divide that with the dry food that was eaten and times it with 100. So the coefficient is going to be in a percentage. The coefficient is going to be in a percentage. So here's an example, 6.2 kilograms crude protein. Don't worry about the fact that there's protein or fiber or whatever. The fact is we know the animal was given 6.2 kilograms of feed to eat. So they consumed it, and then 1.8 kilogram was eliminated in the feces. So put that just into your digestibility coefficient. It is 6.2 kilograms minus 1.8, because you don't want to know what it excreted. You want to know what it actually absorbed. So you have to minus what was eliminated out of the body. and you divide it by 6.2 kilograms, which is the total, times 100, and then you get 71% of the crude protein was actually digested. So what this means is that 71% of the crude protein the animal actually took in or ate was absorbed in the body. So this is actually a good thing. It's a good value. It's a higher value, much higher than 50%. If that percentage was something like 20%, it is a reason for the farmer to panic, because that means everything, mostly 80%, was excreted out of the body with the manure. So the fact is the farmer would be losing money. But the fact that it's 71% that was absorbed is a good thing. So the animal actually gained some feed and nutrients. Hopefully it's still growing, or it can be used for maintenance. So here's just an activity. I would recommend at this point, if you want to do on your own, pause the video because the next slide will give you the answer. Okay, so in this case, a cow consumes 12 kilograms of hay, but there's a moisture content. And in the equation, the bottom here, it says it wants dry food ingested and dry food excreted. So you have to figure out, if 9% is the wet feed, obviously what's going to be the dry feed. Okay, then they also give the cow excretes 5 kilograms, but that is wet manure, and 60% of it is wet. How much of it will be dry? Okay, then you have to calculate the coefficient. So here's your answer. Firstly, okay, this is the long way. You could have, instead of saying 12 times 9%, you could have said 12 times 91%, because 100% minus 9, that gives you basically the dry feed. And then you will already get or come to 10.92 kilograms. So this basically is your dry feed. This was feed that still had moisture in it. Okay, then for the manure, the same thing. You could either use 60% or 40. If you said 5 times 40, you would have come to 2 kilograms. So then you just have to substitute all the dry stuff in. So for your coefficient, 10.92 kilograms minus 2 kilograms, dry feed, dry waste, divided by the dry feed that was ingested, so the total of the dry, times 100%. Then you get 81.68%. So this is also a very, very high percentage or coefficient, which is good. So 81%, roughly, or 82% was absorbed by the animal, all the nutrients. And just a reminder, please remember the formula. You guys get a mark for the formula for just writing it. So in this case, I didn't have enough space, so I did not write the equation out in words. But you get a mark for that. Usually 2 marks for this, for substituting everything incorrectly, and then 1 or 2 marks for the answer and saying percentage. Okay, so then we look at the biological value. So the biological value itself is the percentage of absorbed nitrogen. So the previous one was just to figure out how much nutrients was absorbed, but now the biological value focuses on the protein itself, or, well, everything that has nitrogen, which is basically your protein. So I just want to mention that the BV value, or the BV, usually ranges between 0 and 100, so meaning there is 0 nitrogen, amounts of nitrogen in a feed, or there is 100%, technically, percent in the feed. So the ideal protein then would be 100, so the highest, the better. So here I just want to digress and go to this side of this table. Here we can see that whey protein, a whole egg, is very, very high, so it's 94, 96. Usually they say an egg has a value of 100, like here the protein content of feed is usually compared to the BV of an egg, which they say is 100. Technically it's not 100, but since it's so high in the 90s, usually scientists and so on assume it's 100. Okay, so things like a milk, egg protein, whey protein is like protein flour, or basically a protein, is very, very high. So all of the BV value, basically what it does is it compares any food type the farmer wants to give to its animals. It compares its nitrogen content with the nitrogen content of an egg, because an egg almost has 100. So that's your ideal protein you want to give, or the ideal food source. So on this chart, you can see that things like milk, cheese, chicken, fish, beef, and I hope you guys realize that these actually are your animal feedstuffs or animal products. They have a high BV value, so a lot of nitrogen, a lot of protein. But plant-based things like beans, oats, rice, corn, beans has exceptionally lower amounts of nitrogen. So point being here, when farmers have to give or supplement their feeds to the animals and they want the animals to gain more protein, they have to give animal-based protein or food sources to the animals. Then they get a lot of nitrogen in. So proteins from animals have higher BV than that from plants, just said. And lastly, what is basically the purpose of the BV? It helps the farmer to determine the diet of the animal. So again, they want to make sure that whatever the animal is eating has enough protein in. And the farmer can figure out the diet and figure out whether the animal needs extra nutrients or extra supplementation. Then secondly, feeding standard of the animal. So again, it actually goes with the first bullet to figure out whether the animal is eating or what it's supposed to be eating, getting in the right nutrients it needs for either maintaining the animal or for the animal to still grow. And then last, it also helps the farmer for ration formulation. Basically, all 3 of these bullets have to do with the same thing. The farmer has to figure out whether he needs to supplement. Can he just give the animal roughage, which is basically them eating off the felt, or is it needed to give them extra concentrates, which could be like molasses, which has more sugar in it? Does he have to give more carbs or anything else? More vitamins? Is there a deficiency somewhere? So that has to do with that. Okay, then I just quickly want to mention the energy value of feed. So in this case, the energy value or energy is measured in calorie or joules. Usually in our case, we measure it in joule. And this entire equation goes about figuring out whether the animal has gained enough energy. The first one was about nutrients in general. Second one we just mentioned was about the protein content. And just by the way, with the protein content, they usually ask short questions. There wasn't really a calculation to do. But in this case, with the energy, to see whether the animal has gained enough energy, there is a calculation. So overall, when an animal gets feed, we talk about the initial energy they get in as the gross energy. Then at a stage, while metabolism is happening inside the animal's body and so on, some energy that the animal has absorbed goes out the body with the feces. So when you have the gross energy and you minus the energy that was lost through the feces, it is called the digestible energy. So to get the digestible energy, you say the total energy, which is the gross energy, minus fecal energy. Simple enough. So that's how you get the GE. And they usually use GEDEMENE. So you have to memorize the shortened version. So you don't have to say gross energy every time or digestible energy every time. You can use the shortened way of saying it. Then when you have your digestible energy, some energy will also be lost through the urine of the animal and gases through of the animal. So meaning some after, especially for a cow, after the microbes have digested or helped them digest cellulose and lignin and all these tough plant materials in their stomachs, they emit methane gas out their bodies. So it also releases heat into the atmosphere. So that gives us, when you've eliminated these two heat sources, you get, they talk about metabolizable energy, but a better word would be metabolic energy, a little bit shorter. So the ME, metabolic energy. So to get the ME, you have to get the DE. So you work from here. We already subtracted the fecal energy. So then you say DE minus the urine energy and the gas energy. That gives you the ME, metabolic energy. So I just want to mention sometimes they either ask you, they give you the gross energy and they just ask you to get the net energy. So then you just simply minus all these things together, do one equation. But sometimes they ask you to figure out the DE first and then to separately do the ME afterwards, something like that. So that's why there are basically three equations here at the side. Depends on what they ask. So then you have to remember how to do this in sequence. So after you've got the ME, then also energy will be lost through the skin of the animal, through heat energy. So meaning they respire or they sweat and so on, they lose heat through their skins. So then after that, if that is gone, you get net energy. So this is what the animal is left with at the end. So this is actually what they absorb or what they keep at the end. So the NE is then your ME minus heat energy. Okay, so here's an activity. Again, I recommend pause here, read through, and then see if you can find the answer. Answer is on the next slide. So just shortly, they ask you to calculate the net energy. So this one is all the equations in one that a cow will consume from feed of 100 kilojoules energy. That's your gross energy. Then 30% of the energy of the 100 is lost as feces, 8% is lost as gas, 5% lost as urine, and 30% lost as heat. And just a tip, every time you figure out or try to figure out the kilojoules from the percentage, go back to the original amount of gross energy. So if you figure out the 5%, it's going to be 5% of 100, 8% of 100, so on and so forth. Okay, so here's the answer. So basically your net energy is your gross energy. And let me just say the equation at the bottom here then. Net energy minus the gross energy minus feces plus gas plus urine plus heat energy. All those energies together, you minus from the gross energy, and voila, you get the answer. In this case, it's going to be 27 kilojoules. Now, I just want to mention, if you compare this to the 100 kgs, this is horrible. So this animal has lost so much energy just through its feces and through its heat, body heat alone. So this would not be a good answer. Again, anything more than 50%, I want to say, so meaning over 50 kgs, kilojoules, sorry, would be a good thing. So meaning it's about 50. Then also remember to write out the formula. Get a mark for the formula. Even if you make up the formula like this, it's not exactly the formula we saw on the previous slide. Doesn't matter, just as long as you indicate all the energy. So in this case, the net energy, I just included everything. I did not do it in 3 separate calculations or equations. I just put them all in one. That's also fine. Equations. I just put them all in one. That's also fine. Okay, just a last mention. Sorry about this video, it's a little bit long. So the last thing is the nutritive ratio of feeds. In this case, it also looks at the protein content of feeds. So it's a lot like the BV value, but in this case, you can actually do a calculation to figure it out. So they talk about the NR, so that refers to the nutritive ratio. And your equation at the top here is the NR equals 1 to non-nitrogenous nutrients, so the non-proteins, everything that does not have proteins, like your vitamins, minerals, carbohydrates, fats, those things, divided by digestible protein, so all the protein percentage. And we work with percentage, and just by the way, the answer will also be, well, the answer won't have percent, it'll be a ratio. So this is kind of what we're doing here. So the 1 indicates the amount of protein. So it's going to be, this indicates protein, and whatever we write on this side is going to be the non-protein. So to figure out the non-nitrogenous nutrients, you have to have the total digestible nutrients, called the TDNs. You don't have to write out this entire thing, you can just say TDN. So that refers to the total digestible nutrients, which is everything, even the protein. So that's all nutrients the animal ingests. Then you minus it with all the protein you have. So basically that gives you this, the non-nitrogenous nutrients. Usually they must give you the TDN, all the nutrients the animal has absorbed, but you don't want to include the protein in there because this side will include the protein. You want this side to be all about the non-protein. Okay, so just one example. Here they give us TDN as 80%. Okay, that's it. All your nutrients is 80% nutrients of what the animal absorbed or ingested. The protein is 12% of the feed. So to figure out what was not protein, you have to say 80% minus the 12. So 80% was basically nutrients the animal absorbed. We can assume the rest is maybe fiber and water. 12% was protein. 68% then was non-protein. So fats, carbs, anything else. So then you still have to put this into your equation. So then the NR, nutritive ratio, would be 1, so 1 part protein to 68 over 12 non-nitrogen over your protein equals 1 to 5.67. So in this case, you have 1 part protein and about 6 parts basically non-proteins. So meaning you're giving a lot of other types of nutrients to the animal and not a lot of protein. That's all right. That's basically what your ratio is. So this is basically for a ration. What is the farmer doing? How much protein is he giving compared to everything else? So that's trying to figure out the ration. So what does it mean in this case? For every 1 part protein, 5.67 parts are digestible nutrients, so meaning everything else, fats, carbohydrates, so on. So the NR is, in this case, narrow. So you guys must be able to say whether it's narrow or wide. In this case, it's narrow. Why? Because 5.67 is still less than 6. So if it's less, this area, less than 6, it's narrow. If it's more than 6, it's wide. So in this case, it's narrow and used for production, reproduction, or growth purposes. So basically, when it's narrow, it means technically you're giving more protein, or a higher amount of protein compared to everything else. So it's still more non-protein you're giving, but in this case, it's, I want to say almost equal. It's not 1 to 1, but think of it that way. It's 5 is closer to 1 than say 6 or 9. 9 is furthest away from 1. So you're giving a high amount of protein. That's the main idea. If it's 1 to 6 or 1 to 10, you're not giving a lot of protein because that 10 indicates everything else. So then it's wide, meaning it's further away from the protein type thing. Okay, again, here's a nice activity. Pause again because the answer is on the next slide. A feed has a TDN value of 75%, so that's all the nutrients, 75%. The protein content is 10%. Calculate the nutritive ratio of the feed, and here's your formula again at the bottom. And here's your answer. So you say percent, you first have to figure out what is the non-nitrogen nutrients, so TDN minus DP, 75 minus 10, which is 65%. Then you can put that into your equation again, so that equals 1 to the 65 then is what is non-protein, 10% is what was the protein, and it gives you 1 to 6.5. Again, no unit used, and in this case, the NR is bigger than 1.6, and that's called a wide NR. 6.5 is higher than 6. Now, this feed is good for general maintenance purposes. So it's just for maintaining the animal. If it's very, very narrow, it's there for helping the animal grow because you're giving more protein. If it's wide, then you're giving the animal less protein and just keeping the animal alive. So it's for maintenance purposes. So it's a low amount of protein. Okay, and that's it for this lesson.